In this video, we're going to look at finding the derivative of a function. We're going to make sure when we do this that we are using this limit definition of a derivative. So first we're going to determine the derivative of f of x. Then we're going to evaluate that derivative to find slope at a given point. Once we have the slope, we're going to be able to write the equation of the tangent line. So a bunch of things going on here, 3 different parts. So let's get started. Keeping in mind what we know about the definition of a derivative. So the definition of a derivative, the general derivative, is going to be the limit as h approaches 0 of, take this function, we're going to have f of x plus h, so plugging in x plus h, minus f of x, which is the original function, all divided by h. So we're going to do this in parts, and we've got the steps for finding the derivative. The first thing we'll need to do would be to find, calculate, and simplify f of x plus h, which is pretty easy for us to see. If we plug in x plus h for 12, we're going to end up with 12 over x plus h. So then we'll find the entire numerator. We'll say, well, let's take f of x plus h and subtract from it the original function. So that would be minus 12 over x. So we'll simplify this, then we will divide by h, then we will calculate the limit as h approaches 0. That's going to give us the general derivative of this function. So you may want to pause and write this down, but I'm going to go ahead and get started. So as we just said, our first step will be to calculate f of x plus h, which means we plug x plus h in for x in the original function, which gives us 12 over x plus h. So the second thing we'll do will be to set up f of x plus h minus the original function f of x. And what that gives us is 12 over x plus h minus f of x, which is 12 over x. So this is my numerator. This piece right here, this expression, represents my numerator. And I need to go ahead and simplify this. So in this case, when we want to simplify that, we're going to look at adding our fractions together. In order to add fractions, you will need a common denominator. In order to multiply something by that common denominator, we can multiply by 1. So I'm going to look at the denominator on each of the 2 fractions, and I'm going to choose that, put that over itself with the other fraction so that we are multiplying by 1. So looked over here, 12 over x in my denominator. I'm going to multiply this first fraction by x over x, and then I looked at 12 over x plus h. I'm going to multiply my second fraction, 12 over x, by the quantity 1, x plus h over x plus h. I'm going to look at simplifying that. That gives me 12x minus 12x minus 12h. Notice I distributed minus 12 times x minus 12 times h all over the quantity x times x plus h. So continuing to look at simplifying this here, the 12x's go away, and I have negative 12h over x times x plus h. So now this represents my simplified numerator. So now that I've simplified that, I'm going to take that, I'm going to divide by h, and I'm going to apply my limit in front of it. So for our last part here, we're going to be able to say that, well, f prime of h equals the limit as h approaches 0 of my numerator, which is negative 12h over x times x plus h, all divided by h. So I've set this up. I need to simplify this. I want that h to cancel. Well, one thing that we want to remember, dividing by h is the same as multiplying by 1 over h. So this is the same as writing the limit as h approaches 0 of 1 over h times negative 12 over h negative 12 times h times x plus h. So divide by h is the same as just putting times 1 over h in the front. Just to think about the divide by 2 is cutting something in half. Multiplying by 1/2 would cut something into 2 pieces as well. So at this point you see h in the denominator, h in the numerator, that cancels. We have the limit as h approaches 0 of negative 12 over x times x plus h. Once I've canceled this h value, now I can plug in 0 for h. When I plug that in, I no longer have to write the limit part. I have negative 12 times x plus 0, which is negative 12 over x times x, or negative 12 over x squared. So negative 12 over x squared represents my derivative. Now notice I wrote f prime of x, so I said my derivative is equal. It's really important, especially when we're learning, but it's really important to write what your calculation is. So this f prime of x, I need to see that on your paper. You don't have to write it every time as long as you're writing your equal signs as you work. I know that they are equal to, but f prime of x is my derivative, and my derivative is equal to negative 12 divided by x squared. All right, so now I'm going to go ahead and clean this up. So back up to the top of the screen or the top of the page, we have found the derivative, right? We found the derivative using our limit definition of a derivative. So we have the original function is 12 over x. We have our derivative, which will give us the slope, is negative 12 over x squared. So we are going to evaluate the derivative so that we can find the slope. So plugging that in, f prime of 3, that gives me negative 12 over 3 squared, which reduces or simplifies to negative 12 over 9. 3 goes into 12, negative 4 times, 3 goes into 9, 3 times. So the slope, then, for our second part here, the slope at x equals 3 is m equals negative 4/3. So we have found 2 pieces. The third piece we're asked to find here is to write the equation of the tangent line. So we'll use our point slope formula for that. And in order to use our point slope formula, we need both a point and a slope. I have an x value, but I don't have a corresponding y value. However, it's pretty easy for us to get that corresponding y value because I'll take 3 and plug that in. So my point comes from the original function. F of 3 is 12 over x, in this case 3 or 4. So I have a point here at plug in 3, get out 4. So the point came from my function, the slope came from my derivative. And if I wanted to write the equation of the tangent line at that point, I'm going to use my point slope formula. So y minus y1 equals m times x minus x1. Now I presented this to you before. It looked a little different, just like this, which is exactly the same thing because the derivative is the slope. And instead of writing y sub 1, I've written f of x sub 1, the output at x sub 1. So continuing through, I have y minus 4 equals my slope, negative 4/3, times the quantity x minus 3. Here we will just simplify, and then we have y minus 4 equals negative 4/3 x plus 12 over 3, or plus 4. I'll add 4 to both sides. Y is negative 4/3 x plus 8. So let me clean this all up again so we can see it all on one page. We have found our derivative. The derivative was f prime of x equals negative 12 over x squared. We found the slope at that point was m equals negative 4/3 by plugging 3 into the derivative. We found our ordered pair, which the question didn't ask us to find, but we needed to find it to calculate the equation of the tangent line, was 3, 4. I took 3 and plugged it into my function. And then the equation of the tangent line at that point is y equals negative 4/3 x plus 8. So that was using the slope and the point and my point slope equation to write that equation of the tangent line. So we're really taking all of these different concepts and applying them together. And on your homework, you may have a question where it asks you to do all of these things. You may have a question where it asks you to find the derivative and plug a value in, or maybe you just have to find the derivative. All right, so just make sure you're reading your homework questions carefully, but this really encompasses, all of what we needed to look at. If you do have any questions, please feel free to reach out for help because that's what I'm here for. Thanks. Have a good day.